Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 28, Measurement Production Problem. How observers and systems co-write outcomes. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. You are moving deeper into Book 9.7, Self-Reference and Closure, of Episode 9, The Generative Grammar. In our last part, we crossed the threshold into self-reference. We saw how the phi field can fold back on itself, creating subsystems, minds, models, maps, that represent other parts of the field. This set the stage. But now we must confront the central, gritty, practical act of self-reference: measurement. This is where the rubber meets the road. This is where an observer, a complex phi pattern like us, reaches out and asks a specific question of the world. Is the electron spin up or down? Is the photon here or there? What is the temperature? The outcome of that question seems definitive, singular, and it becomes a piece of data, a record, a new fact in the universe. But in the holophase picture, this is profoundly puzzling. The observer is made of phi. The system being measured is made of phi. The interaction between them is a phi process. So why does this interaction produce a single, definite outcome, when the underlying phi dynamics might allow for many possibilities? Today in Part 28, Measurement Production Problem, how observers and systems co-write outcomes, we tackle this head-on. We will see measurement not as a passive reading of a pre-existing value, but as a co-production, a grammatical interaction where the observer and the system together write a new sentence into the ongoing story. Our anchor image is a master scribe and a wise elder in dialogue. The elder holds a complex, multifaceted truth, a story that can be interpreted in many ways. The scribe has a parchment and a quill. The scribe asks a direct question: Elder, what is the moral of your tale? The interaction, the question, the elder's considered response, the scribe's act of writing, produces a specific, indelible phrase on the parchment: courage over comfort. That phrase was not simply in the elder before the question, nor was it solely in the scribe's mind. It emerged from their interaction. The parchment is now changed forever, bearing a record. And the elder's story is now, in a subtle way, shaped by having been asked that particular question. Today, we learn the grammatical rules for such dialogic productions in the holophase field. Here is the precise and famous puzzle of this part. In the quantum dialect of physics, a system before measurement is often described as being in a superposition, a weighted sum of many possibilities. The act of measurement seems to collapse this superposition into one definite outcome. But if both system and apparatus are just complex arrangements of phi, obeying continuous deterministic or stochastic phi dynamics, where does this sudden collapse come from? How does the smooth, waving field of possibilities produce a sharp, single fact? And who or what counts as an apparatus that can trigger this production? The holophase answer begins by rejecting the idea of a separate, classical realm that magically collapses quantum systems. Instead, it insists on universal grammar. The same phi rules apply everywhere. So, we must find the answer within those rules. The key is to recognize that a measurement is a special kind of interaction between two phi subsystems. It is an interaction designed to create a stable, durable record. Let's break down the grammatical production of a measurement. 1. The prepared system. We have a phi subsystem in a specific, delicate state. In quantum terms, this is a superposition. In holophase terms, it is a phi pattern that is coherent and unstable with respect to certain kinds of interactions. Think of it as a pencil balanced perfectly on its tip. It holds many possible falling directions in perfect, unstable balance. 2. This is another, typically much larger and more complex phi subsystem. It has a key property. It possesses many internal degrees of freedom that are poised to be pushed into one of several very distinct, stable configurations. Think of the scribe's parchment, which can accept ink in many possible patterns, but once ink is laid down in a specific shape, it is stable and readable. These stable configurations are called pointer states. A pointer on a dial, a triggered Geiger counter click, a specific neural firing pattern. These are pointer states. 3. The interaction, the measurement coupling. The system and apparatus are brought together under a specific controlled interaction rule written in the phi grammar. This rule is designed to be correlative. It links distinct states of the system to distinct stable pointer states of the apparatus. For example, the rule might be, if the system is in state A, push the apparatus into pointer state alpha. If in state B, push it into pointer state beta. 4. The production of the record. Here is the crucial moment. Because the system is in a coherent superposition, the pencil is balanced, the interaction rule tries to do two things at once: push the apparatus toward alpha and toward beta. But the apparatus, due to its many internal degrees of freedom and its coupling to an even larger environment, the rest of the phi field, cannot maintain this coherent split. The two possibilities, apparatus in alpha and apparatus in beta, decohere. They become dynamically separate, non-interfering branches of the overall phi field. This is like the scribe's hand trying to write two different phrases at once, causing an ink blot that resolves unpredictably into one legible phrase or the other. From the internal perspective of a branch, say the branch where the apparatus ends up in alpha, it appears as if the system was always in state A, and the interaction simply recorded that fact. A definite outcome has been produced relative to that branch. The record, the pointer state alpha, is stable and durable. 5. The outcome. The measurement is complete when the correlation is fixed and the record is stable against further interference. The system and apparatus are now entangled in a specific way. The overall phi pattern says, apparatus reads alpha and system is in a state consistent with alpha. This is the new co-written sentence. So there is no mystical collapse. There is a dynamical process of branching and decoherence that, from within a branch, looks like a collapse to a single outcome. The probabilities for which branch an observer finds themselves in are given by the famous Born rule, which in Holophase terms should emerge from the geometry of the initial superposition, the weights of the possibilities, as a kind of measure over the branching tree. Let's explore the triunity of measurement production, the time echo of measurement, the irreversible production of a fact. Before measurement, time evolution is reversible and coherent. After the measurement interaction and decoherence, a new historical fact exists. The apparatus pointer reads a specific value. This fact is quasi-irreversible because reversing it would require controlling all the environmental degrees of freedom that cause decoherence, a practical impossibility. The time echo is this arrow of record-making. Measurement writes a time-stamped entry into the universe's ledger, moving a potentiality into a frozen actuality in the timeline. The space echo of measurement, the localization of a pattern. A measurement often localizes something. A particle's wave function, spread out over space, becomes correlated with a detector click here, not there. The space echo is the pinpointing of correlation. The sprawling, wave-like phi pattern of the system gets tied down to a specific, localized phi pattern in the apparatus, a flashing pixel, a sound from a speaker. A global possibility becomes a local fact. The motion echo of measurement, the guidance of future action. This is the pragmatic core. The recorded outcome guides subsequent motion. If the Geiger counter clicks, you move away. If the thermometer reads high, you adjust the thermostat. The motion echo is information-driven navigation. The measurement produces a stable phi pattern, the record, that then becomes an input for other self-referential systems, like a brain or a control circuit, steering their future dynamics. The co-written sentence becomes a stage direction for the next act. Now let's locate this critical node on the master tree. We are on the measurement and decoherence branch within Book 9.7, Self-Reference and Closure. This branch depends on the concept of self-referential productions to have observers, apparati, and on complex, many degree of freedom systems from hierarchical generation. It enables the final step of closure, understanding how a universe of branching possibilities can yield a consistent, shared reality for the observers within it. It is the practical engine that turns possibility into perceptible reality. To ground this, let's light lanterns from clear examples of co-production. A near lantern from photography. Taking a picture with a flash. The scene is dark and ambiguous to your eye. You press the shutter. The flash, the measurement interaction, illuminates the scene in a specific, brief way. Photons from the scene strike the camera sensor, the apparatus, in a pattern that depends on what is there. The sensor's many pixels each make a definitive choice. They accumulate charge based on the light they received. This data is processed into a definite image file, a stable record. The flash changed the scene, briefly adding light, and the scene changed the camera's state. The resulting photo is a co-production. You cannot say the photo existed in the camera beforehand, nor in the scene alone. It emerged from their interaction under the rules of optics and electronics. A middle lantern from medicine. A PCR test for a virus. A swab collects a sample, a complex soup of molecules where viral RNA may or may not be present in tiny amounts. This is the system in superposition. Both virus present and virus absent are possible descriptions. The test apparatus, thermocycler, chemicals, is designed with a specific interaction. If viral RNA is present, it will be amplified exponentially into a detectable fluorescent signal. If not, no signal. The interaction unfolds. Billions of molecular reactions occur. The apparatus ends up in one of two starkly different pointer states, glowing or not glowing. This outcome is a durable record, the test result, produced by the interaction between the sample's specific molecular configuration and the test-designed protocol. The result guides critical future action, treatment, quarantine. A far lantern from quantum optics. A photon at a beam splitter. A single photon is sent toward a half-silvered mirror, a beam splitter. Quantum theory says it is in a superposition of being reflected and transmitted. Now, place a detector in each path. Each detector is a massive, complex apparatus, atoms, electronics. The photon interacts with one detector or the other. This tiny interaction gets amplified into a macroscopic click, a pointer state. But here's the marvel. If you arrange the experiment so that the paths are recombined before detection, you get interference. The photon acts like a wave. If you place the detectors to ask which path, you get a particle-like click. The outcome, wave interference or particle click, is co-written by the photon state and the specific measurement geometry you chose. The question you ask changes the kind of answer you produce. This is measurement contextuality, a direct feature of the grammatical rules. From the camera flash to the medical test to the quantum click, a universal theme. A definite outcome is not merely revealed. It is produced by a specific physical interaction between a querying system and a responsive system, resulting in a stable new configuration that serves as a record. What, then, is the specific language role of measurement? It is the grammatical rule for query-answer production. It is the syntax that governs dialogues between phi subsystems. It answers. If a phi subsystem A, configured as a question asker with pointer states, interacts with a phi subsystem B under coupling rule C, what is the resulting stable phi pattern of the combined system? It is the rule that translates a superposition, a sentence with multiple potential meanings, into a correlation, a sentence that links a specific system state to a specific apparatus state. The core question this part asks about phi is, what are the dynamical conditions under which an interaction between two phi subsystems leads to a stable, irreversible record of a correlation, and how do the probabilities for different possible records relate to the initial state of the system? We are moving from self-reference in general to the specific, outcome-generating act of asking a question of the world. What does this measurement production rule do in the generative process? It generates classical-looking facts, definite values, from quantum-like superpositions. It explains the emergence of a seemingly objective, shared reality via decoherence and branching. It grounds probability, the Born rule, in the geometric structure of the phi field. It connects information to action, providing the mechanism by which models guide behavior. Now, stability and breakdown. The decoherence-based picture of measurement is highly successful and robust for explaining why the macroscopic world appears classical. It holds whenever the apparatus environment has many degrees of freedom, and the interaction is effectively irreversible. It breaks down or becomes ambiguous in the hard limit of closed small systems. If you could perfectly isolate a single electron and a single atom detector from the entire universe, the interaction might remain coherent and reversible. No definite measurement in the classical sense would occur. The picture also faces the preferred basis problem. What determines the set of pointer states? The answer in Holophase must come from the dynamical grammar itself. Pointer states are those phi patterns of the apparatus that are most stable under interaction with the environment, a concept known as einselection. This brings us to our most stringent empirical standard: falsifiability. The claim that measurement outcomes are produced by decoherence dynamics within the phi grammar makes precise, quantitative predictions about statistics and the transition from quantum to classical behavior. The central claim: any concrete experimental measurement must obey the statistical predictions of the Born rule, which must itself be derivable from the geometry of superposition in the phi formalism. Furthermore, experiments designed to probe the quantum to classical transition, such as monitoring the gradual loss of interference as a system is coupled to a controlled environment, should show data consistent with decoherence timescales calculated from the phi model of the interaction. A concrete measurement scene: a squid-based qubit decoherence experiment. A superconducting quantum interference device, SQUID, can be engineered as a qubit, a quantum two-level system. Its state can be a superposition of clockwise and counterclockwise supercurrent. This qubit is coupled to a controlled environment, a noisy electrical circuit whose temperature and coupling strength we can vary. We prepare the qubit in a known superposition. We then let it interact with the noisy environment for a variable time, tau. After this time, we perform a quantum state tomography measurement to see how much of the original superposition coherence remains. We plot the coherence versus the interaction time tau. The pass condition, validation. The measured loss of coherence follows an exponential decay. Coherence equals initial coherence times e to the power of negative tau divided by t sub 2, where t sub 2 is the decoherence time. The measured t sub 2 decreases, decoherence happens faster, as we increase the coupling strength to the noisy circuit or raise its temperature, exactly as predicted by the phi-based decoherence calculation for this specific setup. The experiment demonstrates that the production of a definite outcome is not instantaneous, but a continuous process of information leaking into the environment, and its timescale is predictable from the microscopic phi grammar of the interaction. Furthermore, statistics over many runs confirm the Born rule probabilities. The fail condition, falsification. Coherence does not decay exponentially, or decays at a rate completely independent of the environmental coupling, contradicting the decoherence model. Worse, if we observe stable, persistent superposition states in macroscopic objects clearly coupled to a warm environment, a squid pointer simultaneously showing both clockwise and counterclockwise as a definite measurable output, it would falsify the entire decoherence explanation for the classical world. If the Born rule is systematically violated in well-controlled experiments, for example, probabilities coming out as the square root of the amplitude instead of the squared amplitude, the geometric derivation from phi would be wrong. Such results would force a radical overhaul of quantum theory and its integration with the Holophase framework. This falsifiability ensures that our approach to the measurement problem is not wordplay, but physics, vulnerable to being proven wrong by a beautifully designed experiment. Let's cultivate a practical recognition skill. You can train your perception to see measurement as co-production in any situation where a probe interacts with a system to produce a record, and where the nature of the probe influences the result. Watch a pollster conducting a survey. The pollster, apparatus, with a specific set of questions, measurement coupling, interacts with a population, system. The interaction produces a data set, record, a percentage favoring a candidate. This result is a co-production. The wording of the questions, the measurement basis, can significantly change the outcome. The population's opinions are not a single pre-existing number. They are elicited and shaped by the act of being polled. Observe a scientist using a probe microscope. A sharp tip, probe, is brought near a surface, system. Their interaction, tunneling current, atomic forces, produces a signal that builds an image, record. The image is not the surface. It is a representation co-determined by the properties of the tip and the surface. Use a different type of tip, a different measurement coupling, and you get a different kind of image, revealing different properties. Consider a conversation where you ask for advice. Your state of mind is complex, with conflicting impulses. You pose a precise question to a friend. Their response, shaped by their own nature and your question, becomes a definitive piece of advice you act upon. The advice is a record produced by the interaction. It resolves some of your internal superposition into a committed course of action. Whenever you see an interaction that crystallizes ambiguity into a specific, actionable record, you are seeing the logic of measurement. You are seeing a question and an answer being co-written. We must connect this pivotal insight directly to our holophase journey. In the previous part, we saw that observers are self-referential phi patterns. Here, we see how those patterns perform their core function. They measure. They ask questions of the world, and through grammatical interaction, they co-produce the definite outcomes that populate the reality. This completes the loop of self-reference. Not only does the universe contain models of itself, but those models are actively built and updated through these measurement productions. We haven't added a special collapse axiom. We've identified the dynamical grammatical process, decoherence and branching, that within the one field accomplishes the same result. If you want to see the full mathematical derivations and exact equations behind this idea, the detailed models of system apparatus coupling, the master equation for decoherence, the derivation of pointer states, and the Born rule, you can search for Holophase on Zenodo. There, you will find the scientific papers that this audio journey is built on. Let us pause and feel the weight of this step in Book 9.7. We have demystified the central enigma of quantum theory by embedding it in the broader grammar of phi. Measurement is not a boundary where physics stops. It is a particularly important type of story that the universe tells about itself. But the major question remains. If measurement leads to branching, many coexisting outcomes in the global phi field, why do we, as observers, experience only one branch? How does a consistent, single reality emerge from the perspective of the observer within the story? This leads us to the final part of this book, the closure of the loop. We will explore how the holophase grammar ensures that for the observer pattern on a given branch, its reality is consistent, singular, and logically closed. Before we end, the mandatory zoom out to hold our scope. Measurement productions, decoherence, pointer states, these are all dynamical processes of the phi field. The collapse is an effective description of branching from within a branch. The probabilities are measures on the geometry of initial conditions. We have added no new substances, no external observers, no special collapse postulate. One field, phi, plus its infinite tower of derivative questions, plus the complex dynamics of self-referential subsystems. From this, the universe generates not only things and thoughts, but the very process of questioning that binds them together into a world of definite facts. As we conclude, hold the image of the scribe and the elder. The elder's wisdom is the complex, superposed phi field. The scribe's specific question is the measurement coupling. The parchment is the apparatus with its pointer states. The written phrase is the stable record, the outcome. The holophase universe is an endless conversation of this kind, where every measurement is a moment of dialogue, and every recorded fact is a phrase co-authored by the world and the witness. We have just learned the grammar of that dialogue. Salam and peace be upon you.